Hello, my name is Arnaud Delorme, and this is a series of video comparing EEG software pipelines. So this one is about MNE, and the goal is to compare, of course, with EEG Lab. I'm the main software developer of EEG Lab. And of course, this series is going to be extremely objective. So now let's get started with MNE. And here I'm going to use Jupyter Notebook. And so I'm going to create a new Python 3. And then I'm going to call it MNE process 2. For this, I'm using mostly the MNE documentation. So first, I'm going to import a bits dataset, because the goal is to compare pipeline across bits dataset. So actually I found that Googling for MNE is more effective than searching on MNE directly. And so here I'm going to just copy and paste these commands. Import MNE, I've already installed MNE. That's one of the painful thing with MNE, by the way, is that you never have enough libraries, so you have to install them one by one. And if you're not a programmer, this can be daunting, because usually you have to close your notebook, reopen the notebook. You have to install about 10 different libraries. Luckily here I have them all installed, so I won't have to do that. But if you have an error, most likely you're missing a library that you haven't installed. So it's not installed enough to install MNE. You have to install MNE beads. You have to install many others to get everything to work properly. So here I'm going to set the bits path and how do you read bits dataset, reading a bits dataset. So here, actually this is the line I need to import. And this is to set the bits path, so I can just set it to wherever it is on my disk. So my bits root here is parent.ds 003061. So let's see if that works. Yeah, oh, no, it didn't work. Session not defined. So that was another problem I had, is that you have to edit these command lines. It doesn't work by default. Maybe if I put nothing here, it's going to work. Okay, this worked. So bits path has been defined. And then there's several different bits commands. They are mostly for exporting data. There's a bits command at import time that allows you to define the bad channels. So it's marked channels. And every time you import a dataset from this bits folder, they'll be marked as bad. But I've actually found more easier to just import the raw data and drop the channels. So that's what we're going to do right now. We're not going to mark the bad channel. So we define our bits path, and then there is a function to import dataset. So now we're going to import the dataset. So how do we import the data? Reading the data. Here, read the data. Read raw bits. Let's see what happens here. So I finally figured it out. First you have to type bits match, and then you can type raw import bits with the first subject like this. So you don't type subject. There we go. Okay, so that's importing the channels. And then I actually don't want to process these channels, so I'm just going to drop them. There's also an issue with this function. I'll submit a bug report about determining the type of the channel. While brainstorming, EEG Lab determined the type just fine. This function it assigns EEG to 2 of these channels where they're not EEG. So here we're going to drop channel. So raw. Okay, so I've dropped some channels. So 64 EEG channels. I've read my raw data. And the next step is to, I like to set the reference. So I think it's set reference. Set EEG reference. And then let's look it up. Ref channel, I think it's average. Ref channels average. Okay. Okay, I've set the reference. Next, after setting the reference, I want to set the montage. And here, yeah, that's the one I used. Easy cap. Okay, so that's loaded. We can try plotting it. Okay, so it's the full montage, and then we can assign it to a data set. So when we read a data set, set montage. So we're just going to assign it to a data set. And ours is called raw. So this is assigned, and we can plot the sensors. And so MNE takes care automatically of selecting the correct electrodes. So there's much less here than there was before in the actual montage. So next step is to filter the data. I found this command in the tutorial, looking in the filtering section of the tutorial. So here I'm just going to copy it. So it's going to be a high pass filter at 0.5 Hertz. And you can select either linear or non-linear filter. The default is linear filter. So that's done filtering. And then after filtering, I need to extract some data epochs. So I did search for method to reject data, continuous data, and I didn't find any automated method to reject continuous data. There are automated methods to reject epoch data though. And the main one is this additional library that's called Autoreject. So that's not part of MNE itself and has a different website, and you have to do a separate installation. But this was made by MNE EEG, who was working tightly with Alex Sanganchon, who was one of the main developers of MNE. So they're really close to the core. So I trust what he did. Also, I was in his PhD committee, so I read his paper, and most of his thesis was actually about one of these methods. So I'm going to use this method, Autoreject. First, because I'm relatively familiar with it. Second, because I think that's the only one to do automated rejection. But before doing that, I need to extract some data epoch. And this is the part where I struggled, because even though I imported the EEG lab dataset, and even though the events are present, there's some what they call MNE annotations. These are not standard events. And so I need to convert them to event first. And so there was a little bit of searching to convert annotation to events. This is the command here. That's here to annotation to event. MNE. That's this one. So this line will do. So raw. And once I've done that, so you have an event dictionary that assigns numbers to your events. And actually MNE can only extract epoch based on these numbers. But you can give it a dictionary so it can find the annotation which correspond to these numbers. I think, like, compared to EEG Lab, for example, EEG Lab, you can have strings, you can have numerical events. You don't need to have annotations and events separately. So it's a little bit of juggling here to figure out how to do that. Also, even though the MNE documentation is really good, this is not a part where it's excelling. I mean, it took me some time. You see here, this is not in the official documentation. This is in the community discussion. So now I'm ready to epoch, and so MNE extract epochs from events. So first, I'm going to extract the epoch, just copying and paste here. So if it's where you have to copy the event dictionary right here, and this is where you put the events from annotation, and that should work. Let me show the epochs. And it has responses to different types of epochs. Here it shows you different types of epochs. So I'm going to select only the oddball with responses and the standard. And so this is a P300 experiments, some sounds, beep, 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 boop, beep, beep. And so the beeps are the standard and the boops are the oddball. So I want to see the response to the oddball. And we use the same data set for our experiment, and it's also available in the description right here. The whole bits is available. But so let's just select these two events. And here I'm going to call it epoch all. And here I'm just going to select this specific events. I think you do it like this. Okay, so these are been selected. And now the next step is to reject artifact. And for this, it took some searching. So Autoreject MNE. And so that's a different website. You see it here, how to install it, etc., how to use it. And then you go to the example processing workflow with MNE and Autoreject and ICA is what I used. I've run ICA. Actually, we can just run it right now. So let's run ICA. The issue with ICA is that here, let's run it. So by chance we have the right, oops, do we have the right reject log? We're just going to read on all the epoch before rejection. So it's fitting ICA and running PCA first. And then I can plot the components. Where is this? So plot components like 1 to 10, for example. First 10 components. And so the it plots them twice because there's no output, so we just put an output, so it doesn't plot them twice. So the issue here is that I couldn't find any method to automatically detect which components these are, you know. So this is lateral eye movements, this is most likely blink, but there is no way to assign, okay, this one is blink, 2 is lateral eye movements. You have to select them manually and then you can remove them. So that's not suited for automated pipeline. In EEG Lab, you have different methods to automatically select this component, but you don't in MNE. So unfortunately, I couldn't use ICA. If I was processing the data manually, I would be able to say, okay, I want to exclude these components and then remove them from the data. But here, I'm not going to do that because I can't select these components automatically. So I'm just going to use the Autoreject method without the ICA decomposition. Autoreject without any other processing. So let's just do that. And the Autoreject function is not necessarily super easy to use, mostly because it's very mathematically oriented. So you have to set cross-validation and then the different method, etc. But they've written a paper about it, so you can look at the paper. I'm just going to use the default that we recommend right here. So let's see if that works. Autoreject is not defined, so that's the one where you have to import it. Okay. So now it's doing automated rejection of the data. So while this is processing, I'm going to see how we can plot is there a reject log? Yeah, there's a reject log. So let's plot the rejected epochs. So these are the ones, the rejected epochs. Now that it has dropped some epochs, so I'm going to use this epoch AR now. And now the next step is to compute the average. That's not this one. Epoch AR standard. And then the oddball. Oddball responses. Okay, and now we want to plot them. So let's see. Plot. Topo map. So let's try that. Standard topo map. We're just going to plot it at 0.3. And we're going to do the oddball as well. Let's see. Oh, here I put negative time. Okay, so we plotted our standard, our oddball. And now we want to export back the data to process it on EEG Lab to be able to compare the pipelines. So to do that, we're just going to export all the epochs. So we just use this epoch AR export and then test.set. So it export by default as an EEG Lab dataset. Let's see if that works. Overwrite true, so I have to set overwrite to true. And it wrote it. There is a warning here, invalid events. I asked the MNE developer, they told me it had been fixed. But I don't have the version. It's like a development version, and I have installed the standard version. So this is it for the MNE presentation. I think the pros and cons I've encountered here is with MNE, the event handling, that's not that's not easy with the annotation and the events. Also, using interactive window. I haven't used interactive window here, but you can change the setting here to pop up some windows, and then you can interact with the windows. But it isn't clear when you select epoch or you click how the data goes back to actually the command line. So I don't know if the interactive window are really that useful as compared to MATLAB, for example, where it would update the workspace. It's harder to do that in Python, to have the plots actually update the Jupyter Notebook. What I like though is the very extensive documentation. You search for something, the functions are very well documented, and you can usually find what you need relatively easily. What I didn't like though is you don't have direct access to the structure of MNE. Like for example, I can type epochs, epochs AR, and then you can type info, and that gives you access to part of the structure. Is it info like this? Yeah. It gives you access to part of the structure. Put print. And then you can look at digs, for example. So some substructure of that. Digs. So this is the digitized electrodes, and you can access one of them. So these are structure in the FIF format, and they're not documented. It doesn't matter that much because MNE has interface to these structures. So this is object oriented. So this is an object, and you can actually modify everything inside the object using functions. But you don't really have access to the internals from my knowledge, or it's not documented, and that can be problematic if you want to go deep and debug to directly access the structure. In EEG Lab and Field Trip, for example, you're much closer to the internals because you work directly with the structure which are used by EEG Lab. For example, here you always have to find a function, set channel, get data, etc. And again, it's not really an issue, but as a programmer, I prefer to have direct access to the data structure, especially when it's possible, because it's possible here with MNE. It would be possible if they wanted to do that. The reason they didn't do that is they use the FIF, so FIF structure, which is an MEG structure, which I think is very, very complex. So that's why they didn't want to expose that to users. The last part I want to mention is about using a notebook versus the MATLAB command line. And for people who are familiar with MATLAB, even though I can copy and paste code, if I want to start a loop right now, to loop across dataset, it's not that simple because everything needs to be in a block. So I would have to create a single block and then copy everything within the block, and then I can create a loop. So for the MATLAB user, it's just not that flexible. And then if you have something in the loop afterwards, everything is indented, so you can't copy and paste anymore onto new cells, because then you have to de-indent everything or indent it properly so it's properly executed. So that's why I personally don't like about the Jupyter Notebook as compared to the MATLAB interface. I would also say that Python is more advanced language than MATLAB. It's more for programmers. MATLABs and R are very abstract. They're for people who don't necessarily know how to program. Python is for somebody who knows how to program. And if I didn't know Python, it would have taken me days to figure out first which Python version to use, then how to install the libraries, etc. There's a steep learning curve if you're not a programmer to using Python. And I would definitely advise to use MATLAB or R instead, which are more abstract language. made for people who don't necessarily know, are not expert programmers. So thank you for your attention, and then I'll see you in another video where we actually compare these different pipelines.